Okay, so we are recording now, everyone. So thank you for joining this demo session, guys. My name is Roshan. I'll be the instructor for this course, which I'm coming up with Cloud Performance Engineering and DevOps and SRE, Site Reliability Engineer. The course, full-fledged course. I'll talk about the course and how we have planned this course, the content of this course, what all additional things we are going to provide with this course, how we are planning, what is the thought process behind this course. So we'll talk about all of this, and we'll take up your questions if you have any doubts, concerns, how we're gonna talk about things. You can go in detail about this. Okay, so let's get started. So before I start with the course content, let me introduce myself, everyone. So my name is Roshan. I have around 16 years of experience in IT. Currently, I'm working as a principal SRE with one of the retail giants. I'm the consultant there, principal SRE consultant in DevOps. Started my career as Java developer, and then I moved into performance testing, engineering, used various tools along the way, LoadRunner, Jmeter, Rational Performance Tester, Oats, Oracle Application Testing Suite, Gatling. Locust, I started up, but I could not continue. The project got, we could not continue on the Locust part, but I have like, this decent experience with the performance testing tool. On the engineering, I was involved into tuning code optimization, looking into the code, finding the issue, where the code is taking time, coming up with the right data structure algorithm. Basically, I was helping developers to understand the code optimization from performance engineering point of view, not just finding the issues, but helping them write the efficient code, talking about the bigger notation, which code takes lesser time to execute, because that's what matters when it comes to code execution. Okay, so I was there, and then I would say from 6 to 7 years, I'm completely into cloud. I used to work from on-prem in the beginning, but currently 6 to 7 years completely into cloud. I have been working with multiple cloud service provider, AWS, Azure, and GCP. I'm certified in all of them. Not just the cloud, but into DevOps, all the tools that I have been using, Terraform, Kubernetes, I'm CK certified, Terraform, Ansible, shell scripting, using shell scripting and Python scripting to automate all the mundane steps, right? And now my role is also into the production, being SRE from last 4 to 5 years, taking care of production availability, reliability, disaster recovery, high availability. So that production, we don't want downtime. No one wants downtime. So how to ensure we don't have downtime, or even if we have, we are least impacted. So taking care of the HA and DR scenarios. Worked with various technologies, Mongo database. On the database front, I have been working with Oracle, MySQL, Mongo database, RDS, relational databases that we have in AWS, time series database, Influx and Prometheus mostly. That's on the database. On the in-memory database, I have been working on to Hazelcast and we have in AWS as well cache memory, Redis cache. So I've been working on these things. Currently, I'm working as the principal SRE. In short, you can understand like taking care of production. Production is highly available. We don't have any issues. So that in short. I take up this hobby of teaching of this 4 years back. 4 to 5 years back, I take up this. So I like to share my knowledge on day-to-day basis. So that's brief about me. I hope you got a understanding about my career. Okay. So before I get started, guys, this is going to be the agenda for the session. We'll talk about how the software has been developed and evolved, deployed, the evolution of software development and deployment over the years, how the software has evolved. And then I'll understand where the cloud comes into picture, DevOps come into picture, microservices comes into picture, and containers. So I'll just try to give you a brief perspective of where the technologies are, what you should be focused on. Then you will understand the things better, and why this course and how the course is planned, you will understand this. So let me get started, guys. Okay, so before I get started, okay, so I'm hoping those who have joined this demo most of us are from performance engineering, testing background. Is there any other background that we have in this forum right now? Like support engineer, cloud engineer, those who are trying to be SRE, not from a performance background as such. Do we have anyone? Because I'm going to assume that most of us are from performance background. We understand what is response time, what is contention, resource contention, those things, right? Is my understanding will be correct, guys? Please give me yes on the chat. Is everyone from performance background here?
Yes.
Okay. Okay.
Sure.
Sure. So even I expected the same. Good. So I got two responses. Keith, AD, Silpa, looks like yes, all yeses. Okay. Tafim, Mohsin, SV, Hari Kumar. Okay. Looks like Arun Kumar. Yes, everyone. Good. So now I would like to ask a simple question. Okay. From all the performance engineers, testers out there, do you think, based on your current roles, responsibilities, or where the interviewers are asking questions, do you think that apart from knowing the performance testing tool that you know, the LoadRunner, the Jmeter, the Gatling, right, or the monitoring part of it, either you do it from Dynatrace or AppDynamics, apart from those things, do you need to know these things as well? Do you think so? DevOps, when I say DevOps, automation, microservices, when I talk about microservices, how it is deployed, containers, Kubernetes, Docker, how the containers are created, cloud. Do you think that apart from knowing the performance testing tool and the monitoring aspect of it, we really need to know all of these things, the words, 4 words that I've used in my screen, right? So Deepik is saying we are all doing deployment as well. So if we have a perf environment, we have to set up our own infra as well, right? Most of us are having that, I would say, the job description of setting up our own infrastructure, deployment, the new deployment, setting up. So we do take care. So I do see a lot of folks, without knowing these things, we won't be able to troubleshoot. That's what Ankit mentioned, right? So exactly, I do agree with you, right? And that's where this course is. I understand the transition that has happened. If you are 4 to 5 till 3 years, 4 years, it's all good. If you know a little bit of scripting, monitoring, you're fine. But when you go deep, the architecture point of view, it's all about cloud now. It's all about Kubernetes now. Everyone is talking about Kubernetes. The deployment, it's all Kubernetes. We need to understand how it is deployed, how Kubernetes helps in production reliability. That's important. How the Kubernetes architectures are. It's all about microservices now. We don't deal with monolithic applications now. Most of the development is happening in the microservices domain. And we have moved into Agile. It's all about deployment, taking the it's all about the automation. In Agile, we had issues, right? There was friction between, I would say that there was delay between the lot of phases in SDLC, a lot of phases. So we would like to streamline, make the process swift using DevOps automation, right? Absolutely. So I'm exactly see that you guys all agreement with me. So let me put things in perspective, right? I'm going to share you the next slide and you will understand why am I talking about these 4 words particularly. There are so many words to talk about, but why these 4 words? You will understand this from the next slide. Look at this. So you need to understand the software development and deployment evolution, how the software has been developed and deployed over the years. What was the situation back then when the software industry started? And what is the situation right now? Where are we right now? So if you look at this, so if you look at the development process as such, we started with waterfall model, right? In the waterfall model, what we did, we developed the entire application at once, and then we started to test it. And if we found any anomalies, some architectural flaws, we could not go back and make changes, right? That was one of the, but something to get started. We should not criticize so much, but that was a scenario back then when things started. We learned and we progressed. We divided the software development into various sprints. We call it different phases. We took the development into phases, and we call this sprints. So this is phase 1, this is phase 2, this is phase 3, phase 4, and we took all the SDLC in. We considered all the SDLC steps: the planning, development, the testing, all sorts of testing, functional testing, performance testing, security testing, penetration testing, UAT testing, user acceptance testing. We consider all sorts of testing in each phase, and then we took the feedback from the customer, and then we moved into the next phase. Then again, we did all the phases here: the development, the unit testing, deploying the code to the test environment, again doing all sorts of testing, QA testing, performance testing, and then we took the feedback again and we progressed to the next phase of development. It was much better. It was much better than waterfall. We were on the right track. It gave us this assurance that we are on the right track of software development. And customer, the client, is in line with the development, with the final product, what we are developing, as right. So it was much better. But again, there were a lot of phases in this. In SDLC, we have a lot of phases. The to and fro, the back and forth communication across the team slowed down the development deployment process basically. So see, what is my end goal? When the code is ready, when the developer is ready with the code, what is my end goal? I want to deploy my code to production. That's the end goal. All the other things are validations. Either it's QA, functional validation, performance validation, or security testing, or penetration testing, UAT testing. It's all about the validations. Those can be automated, right? And that's what DevOps took care. There were a lot of the silos, the teams were working in the silos, and a lot of communication gaps across the team members slowed down the deployment process when the code was ready. And DevOps took care of that very issue through automation. When the code is ready, I want a CI/CD pipeline. I would want automated the code to get built, then next phase of unit testing, and the next phase of deploying the code to the test environment, and then next phase would be to QA testing, performance testing. I want basically all the steps. When the code is ready, right? My code is ready. Developer has wrote code. What is the next step? I want to build this code, some artifact, whatever. It could be jar file or image file, depends. So I got the artifact. I want to deploy this code. So these are the different jobs: 1, 2, 3, and after this, QA testing, performance testing, security testing, penetration testing, UAT testing. Then finally everything is good, deploying the code to production. DevOps took care of this very issue. Why can't we automate this process using CI/CD, right? And that is what DevOps. So we did not change the way we develop. It's still agile in DevOps, but okay, I'm gonna just wait. I request everyone to wait for some time. Let me just complete with what I'm going on. Then we'll take up the question. After this slide, before I go into the course content, I'll take up the question. Okay. Just let me complete that part, the flow. Okay. Then you will understand things into perspective. Okay. So that's what DevOps solves the problem through automation, the process automation. DevOps is all about SDLC automation. Sometimes you can call it SDLC automation or process automation. DevOps is that, and we use various tools to get this, to automate all these phases here. We use various tools. We use Jenkins. We can use some scripting, right? If we have the infrastructure to build, we can use Terraform. We have a lot of tools here. The automation tools. We use those tools so that things are automated. So that things are automated, then you will the human error, chances of human error will be less, right? And the dependency is there. If this job would only run when this is successful, this job would only run when this is successful. And if any job fails, the respective team member would get notified that this particular job has failed. Let's say if the performance testing, or if you're doing testing, if we see that the response time is higher on the new release, we don't want to deploy the code to production, right? If I see from the last build in the performance testing job, let's say this is a performance testing job, and I'm running a test, some 30 minutes test, and I see a high response time for few of the transactions which compared to the last build. I don't want to deploy the code to production. This I would mark this job as failed automatically based on some criteria. I'll compare my test results with the last build test results. We have all the things in Jenkins. Jenkins is the CI tool, one of the very popular CI tool we have Jenkins. So we can use some plugins to compare the test results with the last build test results, and we can mark this job pass or fail. We can stop the code from deploying the code to production. That's a valid thing, but that could be automated. We don't want a manual process, someone doing it manually, installation, missing someone. Like this happens, right? Mostly QA engineer raises a defect and a developer says it's not a bug, you don't have proper dependency, something is not installed in your application, you're not running with the latest code. So there are a lot of things back and forth, a lot of communication delayed the process of deploying the code to production. That's what DevOps solves the problem, right? And we are in this phase. Whatever team you are in, right? Whatever team you are in, you'll be asked to streamline that process. Why should we wait for so long if we can automate things? Whatever possible, let's automate things. So we are into this DevOps phase. So that's about the development process. Okay. Yeah. Any questions till this point of time? So I thought somebody was asking any question. I'm gonna just take a pass. All good? Okay, I'm gonna assume silence. We're all good.
So, Roshan, one question here. You mentioned you were giving an example in the CI/CD pipeline saying you run performance scripts, say for 30 minutes. So basically the whole deployment duration, right, that would increase. So in your experience, what is the time or the duration that you run performance scripts as part of the CI/CD pipeline?
Okay, so it depends on how big my release is. Okay, so you cannot just say for every release it's gonna be 30 minutes. If I know that it's a minor change, right? Not something big has changed, some small defect, somebody has fixed a small bug. I just want to cross check. If it's not a major release which is happening, so I can just go with 30 minutes. That should be. But if you have a major release, lot of modules are getting impacted, lot of code change. We have changed a lot of code, optimized a lot of things. We would definitely want to test a longer, right? So it depends.
Okay.
Okay.
Thank you.
Okay, so that's about the development process, right? The same thing happened on the application architectures. Again, back then when the software industry started, it was all monolithic applications. Monolithic. Everything was monolithic application. When I say monolithic, so consider application layer. So let's say 3-tier application is there. Okay? Web server, your application server, and DB. Okay, let's consider these things. So in the application server, when all the code resides together, when they're packaged together, when all the modules, let's say you have got 4 modules. Let's say you have 4 modules, M1, M2, M3, M4. Let's say that. Let's say you have 4 modules in the application server, and these modules are tightly coupled. Tightly coupled means whatever the functions you have written for M1, M2, M3, M4 are being called anywhere and everywhere, right? Like a single package. They're packaged together. You get one jar file. You deploy all the code together. That's what I'm calling about the monolithic application. There's a huge dependency in case of monolithic applications. Let's say if M1 is not working, or one of the functions in M1 is not working, let's say F5 is not working, it has the potential to impact the entire application, because there is a huge dependency across the modules, because M5 would be called in M2, M3, M4, because there is a huge I'm calling the functions directly across the modules, and they're packaged together. If F5 has some issues, your code may not run properly. It may not build properly. You may not get a good, complete clean jar file. It will have some defect which can flare up the issue in production. So one application can bring the entire one issue, even the smallest issue with one of the module can bring the entire application down. That's the level of dependency. I'm calling it tightly coupled, and that's what the monolithic applications are basically. So we would like to make it independent. How to make it independent? Don't create dependency. Make it independent. M1, M2, M3, M4. Don't call the functions. Create microservices. That's where we are in this phase. When you talk about the microservices, the modules M1, M2, M3, M4 are loosely coupled. We use the word loosely coupled. When I say loosely coupled means I'm not calling the functions directly. I may call the RESTful endpoint, right? Let's say I have a Swiggy application, or Uber application. If I tell you that notification, if a notification is not working, which is at the top right corner of, if you look at, even if you order your cab, book a cab or order your food, you get a notification, right? That your food has been ordered, your cab has been booked. If I tell you notification is not working, you cannot book your cab or you cannot order your food. It doesn't make any sense. Why, if notification is not working, if some issue is with the notification module, why am I not able to book my cab? That's totally irrelevant, right? That was the situation in case of monolithic applications, a huge dependency. And we solve this into microservices. We make the modules independent. Independent means I'm not going to call the functions directly. You can deploy M1, M2, M3 independently. You get one jar. Let's say if this you are writing the code in Java, so you get a separate jar file for M1, separate jar file for M2. You will have a different build lifecycle, deployment lifecycle altogether, separate. If I'm changing a code in M1, I do not need to run a build M2, M3, M4, M5. Those models can be built separately. I can only focus on M1, right? That helps in the HA, high availability, because if M1 is not working, it will impact M1 core functionality. It's not going to impact the core functionality of M2, M3, M4, M5. The core functionality is still intact. So that helps me in better HA. It's not like if M1 is not working, the entire application is going down. So those kind of things, the advantages of using microservices, right, we get over monolithic applications. That is what we call it, the tightly coupled and the loosely coupled architecture, right?
Roshan.
Yeah, go ahead.
Did I call you the right name, Roshan?
Yeah, Roshan.
Sorry about that. Roshan. Okay. So I find it very hard sometimes to distinguish between the agile development process and the DevOps process. I want you to actually put it clear for me on my simplest term, how to understand the difference.
See, as I told you, agile and DevOps is not too different. The way you develop is the way you develop is going to be the same. What is the difference thing? What is the core difference between agile and DevOps is the automation.
Okay, so you mean when you come to the CI/CD, that's the difference between the agile and the DevOps, right?
That's what I'm talking about. See, if you look at the DevOps, if you look at just give me 1 minute. If you look at the DevOps, the way it is designed, it is developed into two words: development and operations. Basically, DevOps is all about the collaboration, the best collaboration between the development and operations. Operations means if you are not a developer, you are into operations. If you are into testing, you are into support, or if you're not a developer, you're not developing the code, you are into operations team. DevOps solves the collaboration issues. It makes the collaboration between the development and operations team smooth. That's what the DevOps do, and it happens through automation.
Okay, thank you. I got it.
Perfect. Okay. So, any question? Do we understand the difference between monolithic application and microservices? What is the core difference here? Are we all good here? Please confirm once.
Yes.
Everyone? Okay. Good. Okay. So look at this now. The next question is, where should we deploy monolithic applications? Where should we deploy microservices? Right. Again, if you look at the way we were deploying the infrastructure back then, when the software industry started, we used to deploy things directly on the physical server. Directly. Back then there was no VM concept. There was no virtualization back then. We used to deploy directly on the physical server. It may be of big compute. Imagine 100 cores and imagine 400 GB of memory. Just imagine, right? And used to deploy some tiny little application, few applications, few KBs, MBs applications. We used to waste a lot of resources. Then around 1990s, 2000, the big revolution came, virtualization, right? And we were able to create VMs. So when you go to any server, any cloud, AWS, Azure, and GCP, you can create EC2, virtual machine, compute, whatever the name you call it, node. That's only because there is virtualization. You are able to customize your VM now, depending on your requirement, depending on what you want to deploy, how big the application is, what's the requirement, resource requirement of the application is. You can customize your server. So virtualization was a great benefit, and we were able to utilize the resources better through VMs. Now, back then, we used to just deploy a few applications in this big infra. Now we can create multiple VMs using the same infra. Multiple VMs. In one VM, I can install web server. In one VM, I can install application server. In one VM, I can install database server. Right? I could deploy multiple applications on these VMs, and I could customize this VM size also based on my requirement. So we were able to utilize the resources better. It's all about the resource utilization, because resource utilization is directly linked with the cost. If you can optimize the resource utilization, that's the best thing you can do, right? As a performance engineer nowadays, the role of a performance engineer, or you can say the cost, is also the important factor. And we are also involved into since we are working on the cloud technologies, the cost optimization is one of the very important aspect of anything right now, because it directly involves the budget. Through performance testing, we benchmark the application, how good it is going to be in production when it will be hit with so many user load, so much of traffic and all those things. We validate that using performance testing. But if you could optimize the cost, nothing like it, right? If you can see that if resource is 10% utilized, and if you're using 8 cores vCPU, let's say, being a performance engineer, if you're using 8 cores vCPUs and 30 GB RAM, if you see that on the maximum load, if you're 10% utilized, so definitely you're oversized. There is a chance, there's a good opportunity to optimize the cost. You can go with 4 vCPU, maybe the CPU utilization go till 30% or 35%. You're able to reduce the cost by half. It's a great thing. It's a great contribution if you look from the cost perspective. So you need to also look into the cost. But again, I was talking about the virtualization. So you were able to utilize the resource better in virtualization. When you're able to create VMs on the physical server, you can deploy multiple applications now. But now, around 2010, I would say 2015, I would say something great has happened again. Just 5 to 6 years back, I would say, not long ago. We are in the phase of containerization. We have observed that even the VMs are overly sized. We are not able to utilize the resource of a VM also. VMs are mostly 10 to 15%. If you look at the current server right now, if you have the exposure, go and check. If you're using a VM, how much peak utilization in a day? If you say 10-15%, so obviously you're oversized. There is an opportunity, you can optimize it. You can suggest this to your managers, your leads, and they would appreciate this, because you're thinking about the cost, cutting the cost on the utilization front. It was observed that the utilization was not high on these VMs. So what we did, in one VM, I can create multiple containers. So on this physical server, you install something called virtualization software like hypervisor or VMware software, and you could create VMs. On this VM, I'm going to install something called container engine like Docker, and I could create multiple containers. I'll just keep it short and simple. you require 3 VMs to run your 3-tier application. Let's say you require 3 VMs, 1 VM for web server, 1 VM for app server, 1 VM for database server. You require 3 VMs, 8 vCPU each, something of that sort, and you are 10% utilized. That can be possible now that in one VM itself, 8 cores, whatever the configuration of a VM is, I can create 3 containers. One container could be my web container, another container could be my application container, another could be my DB container. In one VM itself, I can run 3-tier application. Think about the optimization. And that's what containers brings to the table. It directly impacts the cost, directly. That's why the entire world is appreciating the Kubernetes and the container technology. And that's why the microservices are best suited to deploy in the containers. Because microservices are less code as compared to the big monolithic applications. We are breaking down the code and we are utilizing the VM resource also by in the container. We'll create multiple containers and in each container we'll deploy microservices. So both goes hand in hand. Basically, it's all about the cost optimization. What is at the center? The cost. All these years, whatever I'm talking about, it's all about the cost. If I can save 50 to 60% of the cost, what I need after that, right? If I'm, let's say, my cost monthly budget, monthly running the production is, let's say, I'm giving you a perspective, 30K USD. If I adopt the container, if I adopt the microservices, and if I deploy those microservices on the containers, I'm getting high availability also. And this cost comes down to 15 to 20K. Everyone would love to get that. Everyone would want that. 10K, 15K straight away cost reduction based on the utilization. Perfect. That makes sense. And the microservices are best suited to deploy on the containers. Right. So that's what the world is going about. Like 2010, 2015, Docker came, Docker introduced. Docker is the container engine. Docker introduced the word. Docker Inc. is the company name, introduced something called Docker container engine. You can install container engine on a VM and you can create containers, multiple containers in one vCPU, 1 GB RAM. Trust me, G2.micro, 1 vCPU, 1 GB RAM, I can create multiple containers. I can create MySQL, I can create web container, HTTPD, I can create Tomcat, and I can run it. If I require more, I'll get it. More nodes, more VMs, but I'll make sure my VM is fully utilized first. I don't want to keep my VM underutilized, right? That's the thought process here, containerization, right? And coming to the last phase, back then, if you have a business idea, Amazon.com or any idea, you have to set up your own data center. Very costly. Setting up a data center is a very costly affair. It takes billions of dollars to invest. But now we are in the phase of cloud. If you have a business idea, go to the cloud console, get some VMs, deploy the application, test it, how your user acceptance is. Is business can grow? Yes, can grow. Scale it, more servers on demand. When you require, get more servers. When you don't require, give it back. So easy. I don't have to spend billions, right? I can just manage with 5K USD monthly cost, right? And I can run a full-fledged application in using cloud, using AWS, using Azure, GCP, any cloud service. So that's where. So that's why we're talking about all of these things here: the DevOps, the microservices, the containers, the cloud, and this is what we have right now and going on, and that's what we're talking about. This thing, apart from the performance testing skill set that you have, you should know and involve yourself in the performance testing engineering in these aspects. And when it comes to these aspects, all these things come into picture: the containers, the Kubernetes, the cost optimization, the cloud knowledge, the DevOps knowledge, the automation. You need to know all of this. I hope you guys agree with me. So you now can understand why I talked about those 4 words, guys, and where those words are fit in this entire ecosystem. Sounds good, everyone?
Yeah.
Good. So on that note, right, let me introduce you the course which I'm coming up with. The course is designed on all these 4 technologies that you see, right? It's from the scratch course. Let me talk about the course now. So I'm gonna take you to the course content. Okay. So directly the course content, I'm gonna take it up. So I have broken this course into 2 groups. Okay. One is on the SRE path and one is on the cloud PE path. Mostly both the courses are same apart from the Python playlist that we provide. In the SRE path, we provide Python recorded sessions as well. Okay. And both the courses are aligned the same way apart from the Python that we provide. We have recorded session, we give that. Okay. So I'll just go over it. Okay. You will understand things, how it is planned. Okay. I'm going to share this links with you. You can go over the demo sessions I have taken in the last batch. I'm coming up with now, this is going to be my, I think, 12th, 13th batch, right? I full-fledged, now it's been, the content has been updated, right? So you can understand this. Okay, let me just go over the course content. You'll understand how this course is designed and what's the thought process. So we're going to start with the cloud knowledge. First of all, this course is designed for the people who are in the transition phase, those who are into the performance testing. They know performance testing, monitoring bit of it, and they are trying to be in that, up to the market, up to the demands, IT expectations, the market expectations. So that course is designed for the people who are in that transition, or for the senior folks, those who are expected, the team wants them to work on that efficiently. So the course is designed particularly for them. So in this course, everything is from scratch. My audience, I'm going to assume my audience knows nothing apart from few performance testing tool and some performance terminologies, some bit of monitoring. Is that what I expect from my audience? I don't expect any one of these things. It's from scratch. So I'm going to take up AWS, and it's all hands-on. Everyone would get access to AWS console, right? Everyone. So I have this console. Everyone, I would guide everyone to get an account in AWS and practice along with me, and from scratch. And a lot of things are there in AWS. I don't want to go in detail right now. It will be overwhelming for all of you. But I'll bring you to that level that even you can think of a certification, solution architect certification. I'll bring you to that level, right? You can think, I'll guide you how to proceed on the certification path, but everything is hands-on. So whatever I'm going to talk about, the introduction, cloud computing, if you look at, it's all the basics, VPC, compute services. So 20 to 25 services is what I'm going to cover in this. It's going to be the level of an architect. On that part, I'll talk about the performance engineers needs to understand AWS from an architect perspective, the performance perspective, the security perspective, how the architecture should be. So I'll talk in that. VPC is what I cover in detail. That's what the performance engineer, the VPC auto scaling, the load balancer, RDS, that's what I cover in detail, apart from the basics that we cover, EC2 and EBS, EFS, S3, and other tools, right? CloudWatch is the out-of-the-box monitoring solution. So we cover so many things in AWS. So that's first part of it. And then we talk about, I provide, so again, I'll talk about the term that you're gonna be asked nowadays. What is disaster recovery? What is high availability? What is fault tolerance? Right? I'll talk about these words, how SRE and DevOps are related. I'll talk about what is SLI, SLO, SLAs, what is error budgets. So I'll talk from a performance production point of view, incident management. I'll make you understand what is the SRE role expectations. But right now, if you look at any LinkedIn profile, you're going to find this very alarming, very high demand SRE job opportunities, and the performance engineers fit naturally to that, I would say, right, to those demands. If you just go to LinkedIn and just search for site reliability engineer, you're going to find plenty of job opportunities, plenty. SRE. If you go over all of this, you would understand it's all about those four things that we are talking about: performance testing knowledge that you have, right? And thinking from the operations point of view, how to take care of production, how to make sure production is highly available, reliable. So I'll talk about that as well. So if you are a performance tester engineer thinking to become an SRE, so this is going to be the apt course for you, right? That's what I've designed this course to cater your SRE requirements, right? So go over this, okay? The JD, I'm not going to go over it right now. You can go over it on your own pace. A lot of scopes as an SRE engineer, you would see a lot of opportunities, right? So this course,
For how many years we used to get the calls for this actually? Yes, sir.
can you come again?
Like how many years is required for a SRE engineer, like, as a performance
It's
guy?
all different levels. SRE are required at different levels. If you're a junior, mid-level, or senior folks, SRE is required everywhere. So it again depends. Performance engineers are required everywhere, right? Freshers, 2 years, 3 years, 5 years, 10 years. Same way SRE path, right?
Usually, usually how many years we used to get a call actually? That's what I'm
I'm not
like,
able to understand
2
the
or
question. How many years?
I'm into a performance testing. I
Okay.
learned SRE. If I want to switch my job to SRE,
Right.
like how many years do you
It
expect
will
that?
be a natural shift. That's what I'm trying to tell you. The course will help you get there. Okay. Once you,
Okay.
the course will help you get there. The SRE responsibility, I'll make you aware what all the different roles you're going to be asked to do, right? Because SRE has also a lot of JDs. You may want to be in the troubleshooting SRE. You want to join a SRE team with troubleshooting experience because you have a performance background knowledge. You know how to troubleshoot something, database troubleshooting, application troubleshooting. So you want to join as an SRE as a troubleshooting, not an L1 support engineer, right? So that's where I will
Okay.
take you to the troubleshooting, the JDs, right? Troubleshooting, which requires in-depth knowledge of technologies. So this course will help you get there. That's what I'm trying to tell you. And obviously it will depend on your interest, how much. See, performance engineer or SRE engineer, you need to love the technologies, whatever it comes. Database, you are performance engineers are not a DBAs, but we need to know a lot of things about DB. We don't need to know about full coding, but we need to know about code optimization. We don't need to know a lot about application tuning, but you need to know about the application server admin, like a WebLogic admin. You need to understand where you set the JVM arguments, what all things you do with the GC algorithm, how GC works. So you need to know about the functionality. You are not a developer bit, but as a performance engineer, you need to fit into many roles and responsibilities. I hope you understand this being a performance engineer. You need to love
Yeah.
you need to love the technologies, and that's where the SRE is responsibility is. You need to love the technologies. So there, the core skill is just that's the same. You need to love the technology, adopt the technologies, and do some troubleshooting. The yeah. Okay. So again, I'll talk about the architecture that we have: monolithic applications, microservices, architectures, and then where do we deploy these microservices on the container world, the containerization, the Docker and the Kubernetes. I'll talk about it. Everything is from scratch, guys. So need not worry. What is prerequisites? How much? What you should know? Nothing. Just you just need to be prepared that you need to practice. Just after the session, whatever the things have being discussed, you need to go and practice things, ask doubts next day, and that's what you all need to do, and you will be all learning all of those things. I'll talk about Docker installation, how to you build different containers, different commands that we have. Docker compose, how do you deploy multiple containers at once? What is Docker volumes? How do you create image using Docker file? Container orchestration engine, Kubernetes, I'll talk about it. I'll talk about EKS basically. I'll take up EKS, Elastic Kubernetes Service, one of the services in AWS. Kubernetes is that popular that every cloud service provider has created a managed service. EKS by AWS, AKS, Azure, GKE, GCP, right? We'll talk about that, everything about the Kubernetes. You can see the course content. HPA, auto scaling is very important. That's from a performance point of view. If you don't understand auto scaling, you want to test, right? When, on what criteria you are auto scaling, whether you are able to scale up automatically or not. So I'll talk about auto scaling. How do you enable auto scaling? Both from the containers point of view as well as from a VM point of view. When I talk about the EC2, the AWS, I'll talk about the same, the load balancer and auto scaling group from a this perspective as well. Okay, from the look at this, I think should be here. Okay, let me look at this here. The auto load balancing and elastic load balancing and auto scaling. I'll talk about the storage services, database services, networking. So all of these things I'll take up this in the AWS. So look at this, the entire thing here. I'll talk about the AWS here. So many things, right? And obviously, I understand that people are new to Linux as well because everything happens on the Linux. So I'm going to provide my own self-paced recording sessions, okay, on the Linux part, Linux self-paced recording sessions, which will help you get to the basics of Linux. If you are new to someone from Linux, you get immensely benefited using this recorded session. So I'm going to take up AWS. Along with that, I'm going to provide some recorded sessions for you to get up to speed on Linux skill, right? And apart after that, I just mentioned all the architectures, the Docker, Kubernetes, right? And the DevOps. So I've covered the cloud, the container, and now the DevOps part. I'll talk about a lot of things, how to talk about performance testing job, how do you create performance testing job I'll use Jenkins integration with Jmeter, right? I'll use that. How do you set up email notifications, automated email notifications? I'll talk about all of this. So I'm covering in this course, as I showed you, about AWS, about Linux, about microservices architectures, about Docker and Kubernetes, about DevOps from a performance perspective, right? How performance engineering fits in DevOps. That's what I'll focus on here. How performance engineering fits in DevOps. And then how do you integrate Jenkins with Jmeter? I'll talk about that. Both are Java-based tool, Jmeter and Jenkins. We have a plugin in Jenkins, performance plugin. I'll talk about that. How do you set up jobs there? How do you compare your current build results with the last build result? And on what parameters, whether you'll be able to pass some job or fail, that you can stop or proceed on the deployment. Whether you can take a call, whether you want to deploy the code to production or not. Apart from these things, right, we're going to cover, as I told you, the SRE path. I'm going to also cover the SLOs, the disaster recovery, the HA, fault tolerance, SLI, SLO, error budgets. I'll talk about all those things as well. Apart from this, I'll take up the automation as well. Automation. I'm going to show you how do you work using Terraform. How do you create infrastructure in Terraform? Yes, everything is hands-on. Okay, Silpa. So don't need to worry. Okay, everything I'm going to show you do things. Okay, that this is how you install Jenkins. I'm going to create EC2 instance. I'm going to install Jenkins. I'm going to create jobs. Everything is hands-on. Yes, CI/CD. Yes.
So one thing, Roshan. So you will be doing it, but will you allow us to do it? I mean,
Yeah,
can we also log in
not
and
at the
create
same time.
our own pipelines and deploy and everything?
Not at the same time, but obviously yes. After the session,
Yes, yeah. As an assignment or something, right?
daily assignment would be that practice what I have covered, and ask
Okay.
next session. That would be the daily assignment for you. because our session is like 1.5 hours, 2 hours. I cannot allow like everyone to do it along with me. It will be too
Yeah,
difficult it will be too
I
difficult.
understand. Yeah.
So on the automation part, I'll be talking about Terraform. I'll be talking about Ansible. Apart from that, on the monitoring part, I'll be taking up sessions on Prometheus Grafana because that's very important. Prometheus and Grafana. I'll be also taking up ELK installation. How do you work on ELK? Elasticsearch, Logstacks, and Kibana. So that's what I'm going to cover in this. So this is going to be what I'm going to cover. Live sessions. These things will be live. Everything, whatever I have listed here, whatever I have written here, will be live. Apart from the Linux part, okay, I'm gonna accept this. Okay, everything is gonna be live here. What all will be the playlist, the recorded session? Because I'll be going over AWS, but you will be having access to some recorded sessions as well on Linux. So let me just brief all those things that you will be getting as recording. Okay, so let's hear me out well. So as I told you, first thing on the Linux part, I'll be sharing a recorded session on the Linux. It's been mentioned that only recorded videos provided. I don't want to just so that I want, it's a very basics. Even if you just go over some 3 to 4 hours, okay. I have kept it simple. I have not complicated things in Linux. I have given you the as knowledge what you require from the commands and from the self-scripting point of view as well. 3 to 4 hours of session. Let me show you, okay. Then you will understand what I'm talking about. I'm gonna open all the playlist and show you what all you're gonna get. Okay. Allow me a minute. Okay, that's the link. All are playlist link. Okay, so they are all the playlists I'm gonna share with you all. So let me just open one by one. Okay, so these are all the playlists. So Java performance engineering. I'll not see. I understand that you are from the performance background. So I am focused on the cloud, Kubernetes, Docker, and all those stuff. But along with that, this is my own recorded sessions on the Java P. I'll be giving you the recorded session on Java P as well, some 10 hours of course, which will help you understand Java performance engineering, the thread dump, GC algorithm, the GC analysis, taking thread dump, analyzing memory dump, and all those things. JVM architectures, what is performance engineering? So if you look at this, these are the 9 videos. A simple talks about the basics, the core of Java performance engineering. I'll be sharing this along with this course bundle. This will be the bundle with this course here, Java P. Okay. Apart from that, as I told you, I'll be giving you the self-scripting as well, Linux self-scripting. This. So as I told you, it's just gonna be a 3 hours of sessions, very basics. Okay. 3 to 4 hours, 3.5 hours maximum. Very important. Just I am to the point. It will not take long for you to. I would say this on the very first day when I'll talk about the AWS. I want you to get comfortable with Linux. I want you to know what CD would do, what PWD would do. Right? I don't want to waste time in talking about those things. You can easily just go over it and understand what the ch own would do, ch mod would do, right? How do you change file user groups, right? Basics of self-scripting, top command, awk command, vi editor, all those things, basics. So this is gonna be bundled with the course, these things. Apart from that, Java programming. Okay, so I'm gonna share. We are gonna share because I understand from a Java performance engineering, you need to know Java coding as well. So we're going to provide a full-fledged Java course, coding Java programming course with this course, apart from whatever we have discussed. So in the interest of you to get comfortable with Java, it's a Java full-fledged course, right? This thing, if you look at the Python scripting, Okay, the Python scripting, this is only for the SRE. The people who would be joining the SRE course will be given only the Python extra, apart from the Cloud PE guys. Okay, so this is Python scripting, a full-fledged course. Okay, again, it's a full-fledged course. I would say 30 to 40 hours of course Python coding, which will help you in basically the automation, right? The Python scripting. This is going to be you're going to getting with the course bundled with this. Apart from that, so these two you see that will be given as the day-to-day sessions. So if you look at the SRE course, so you'll be getting everyone. So if people who are getting enrolled to any of the course, you'll be getting this complete playlist on the daily basis. I'll be recording the session as I'm doing it right now. I'm recording it on the daily basis. So this is about the last batch. Look at this, which batch it is. Some of the batches. Okay, September batch. Okay, so look at this. The entire I'm talking. The first 10 sessions is all about the cloud here, and then I've talked about the Docker, the architecture, the Ansible, the Kubernetes, right? CI/CD pipeline. Look at the CI/CD pipeline. I'm talking about DevOps and all of this. So Ansible, and SRE. So well-architected framework, serverless architecture. So all of this. So 40 hours of live sessions along with these videos. So on the videos, as I told you, Linux will be bundled. So all these things will be bundled. So you become a complete performance engineer, architect, or SRE architect role. Okay. So Linux, PE course, Java course, and Python would be given to the SRE people, okay, along with the other things, right? So these things will be bundled, right, along with these 40 hours of live sessions. I'll be taking these live sessions, and this thing will be bundled with the course. Okay. Okay? Any question on this part? What are we going to cover? How are we going to cover? Any question if you have, please ask me. This is only for the SRE people.
Is it a programming is required for this study?
See, I'll ask you this question. Okay, is programming required for the PE course, Java PE? Do you think Java coding would be required if you being a PE, performance engineering?
Somehow, not.
Right. See, that's what. If you're a performance engineer, right, truly, you would talk about optimization, code optimization. You would talk about how to write efficient code, how to write code with less time complexity. You'll talk about big O notation. But most of us performance engineers are only talking about highlighting the issue. But we are not talking about the how to help developers writing efficient code. And that's why this Java programming is useful. If you're thinking that you need that level of expertise in performance engineering, this course is going to help. Same thing for Python. It's all about automation. Self-scripting, if you ask self-scripting is required, yes. If you want to automate stuff, automate mundane stuff, self-scripting is required. If you want to automate mundane stuff like how do you scrape a web page, how do you scrape a file, right? If you talk about Python, right, Python is the most important language from an automation point of view. You can automate a lot of stuff in Python using Python. So that's what we are talking about, to take you to the expertise level. See, you can manage a job without knowing Python, without knowing a shell scripting, but we are preparing you through this course to be on the expertise level. So in the expertise level, you are expected to know Python scripting. You're expected to know Java coding. Expertise level I'm talking about. Okay, so it's not like mandatory. You will find job opportunities where Python is not required. You are able to manage without Python. That's fine. But if you want to automate some stuff using Python, Python is very useful. And that's where we are taking you to through this course. I hope I answered your question. I was able to give you a perspective of things. Yes?
Yeah.
Do you have experience with .NET Core also?
No, I haven't. We have not covered in the .NET. Looking at the market trend, we are mostly first of all, this course basically is going to be applicable all across. Okay, so as part of this bundled recorded session, we are not giving anything on the .NET. Okay, this is recorded sessions. But whatever I am taking up, the cloud part, the Docker part, the Kubernetes part, the Jenkins part, right? Whatever I am taking up, the SRE part, whatever I am taking up, the automation part, the Terraform and whatever this is going to be applicable all across. It does not depend, because I talk at the infrastructure level mostly here. Infrastructure level code could be written in C# or any Java, but in the recorded session I'll be taking up the Java part mostly. Java,
Okay.
Java P on the Java side.
Okay.
I'm going to share these two links with you first of all. Okay, please go over it. Okay, these links, I'm going to put that in the meeting. So bookmark this link and go over the course content. I'm going to walk you over again AWS, and everything's from scratch. Okay, so just be rest assured, everything's from scratch. I don't expect my audience to know any one of these things. All I expect you to have some experience in performance testing tool. You know few troubleshooting. You are good at something troubleshooting. If you look at high response time, what will you do? If you look at high CPU, what will you do? I can expect you to know just scripting part is all I expect. I don't expect you to know all of these things. So that's what my understanding is. I'll be taking up from scratch. So architecture part, Docker part, Kubernetes part, the DevOps part, right? Apart from this, this will be the course given Java P, as I talked about it, and also as I talked about, we'll go into observability as well. We'll talk about Prometheus Grafana. We'll talk about ELK, right? So how to eliminating toil again. So consider both the links. Only extra thing what SRE course would get is the Python coding. Is this what you will get? Python scripting, Python coding. Apart from that, both the course have the same content. Okay, same content. Any question, guys? We are on the top of our hour. Any questions I can help you answer? From tomorrow, we're going to continue, okay? We're going to take up the first session. It's going to be a free session, guys, so feel free to attend. I'm going to start with the cloud part. Basics of cloud, I'll talk. You'll understand how we're going to talk about things. So join me tomorrow to get some.
So are we going to cover any monitoring integration of these Kubernetes or the
Yes.
other areas?
Yes.
So which monitoring, which APM we are going to cover?
We'll talk about EKS, and that's Elastic Kubernetes Service is the AWS service
So
that I'm going to answer.
Okay.
I'm answering your question. EKS is what we're going to use, the Elastic Kubernetes Service, and we have in AWS monitor tools called Container Insights. Container Insights. This is the out-of-the-box monitoring solution in AWS. We'll talk about that. Apart from that, we'll also talk about Prometheus and Grafana.
Okay. So are we not using any licensed APMs like Neuralink?
We can use. See, there are 100 tools. There are 100 tools. But in this course,
that's true.
In this course, we have not put those Dynatrace AppDynamics. We have kept it open.
Okay.
And we are talking about ELK.
Okay.
We're talking about these two.
Okay. Fine. Yeah. Thank you.
Okay, so class schedule is going to be the same. We're going to meet in the weekend, guys. Okay, so look at that class schedule. Just help me understand. So if you look at the links here, class starts at the same time. So tomorrow we're going to meet at 7 p.m. So mostly it will be 2 hours, 1.5 hours to 2 hours, depending on 1.5 hours to 2 hours, consider like that. We're going to meet around 7 to 9. Okay, so tomorrow we're going to meet for 1 hour. That's the free demo sessions. And from the next weekend, we're going to starting up with a full-fledged course. Okay, it's going to be for 2 hours, 7 p.m. to 9 p.m. weekend, Saturday and Sunday. 7 p.m. to 9 p.m. IST, Indian Standard Time, Saturday and Sunday, weekends. That's going to be the class schedule.
Roshan, is it possible to change the time, Roshan? Sorry.
What is the timing you?
I mean, like maybe in the mornings time sometime.
Yeah, we can do it sometimes also in the morning. So not full-fledged. So we can take up something. If you are not doing meeting on the evening, we can also meet in the morning. So it depends. But for now, the plan
No,
is
what I'm saying, like, yeah. Sometimes, like, we might.
Complete change would not be there. So we need to understand. Okay, if we are more people joining the course, talking about meeting up in the morning, I'm fine. But for now, that's the time we are going ahead with. Once we join, we'll see how many people are interested in other times. We'll take a call accordingly. But for now, we are meeting this time.
Yeah, fine.
This time suits well for the US. Okay. US folks, Indian folks, both. So I have taken care of Indian, IST and EST, both time zone. And this suits perfectly well for both the time zone. Okay. So that's why this time suggestion.
Okay.
Look at this. So for the US folks, it's gonna be 8:30 a.m. to 10 a.m. Okay. And again, for the learners in UK, afternoon. So with this time suits for all the time zone. Okay. That's why this course.
Yeah, kind of like it is morning time for US, no?
Yeah,
Sometime
morning
like
for US.
we change it like you will also have Indian time morning and the US in the evening, no?
Evening. So yeah. So see, we can take a call. Okay. See, we need to take a call. Okay. One person, like one person, we cannot do that. So if all of us feel the same way, we can definitely do that. Okay. So that's how we need to.
Sure, Roshan.
And Roshan, what kind of roles and responsibilities is it? We are not like it's not a production support kind of thing, right?
See,
Like some people are is a production support.
I'm talking from the troubleshooting. Okay. So production,
Okay.
we have a lot of things in production. See, production needs to be highly available. So our course is on the troubleshooting part, architecting part, not 24/7 monitoring part. Our course is designed for at a level of performance engineering architect level, the troubleshooting part, not looking into the monitoring, raising tickets. Those are the part of L1. L1 team can do that. So we are part of L2 and L3. So this course is designed for these people, the troubleshooting, the architecture people, not from a L1 perspective. So 24/7, we are looking into monitoring some APM tool, raising ticket based on some issues. So we are not doing that, right? So troubleshooting and architecting perspective.
So like we also need to work on, 24/7, something if you pick up this role.
See, you need to understand what I'm talking about this course, how this course content is designed. SI has many roles and responsibility. Do you want to be a performer? First of all, you need to ask yourself, what do you want to see? Where do you want to see yourself in 5 years down the line? Just ask this question to yourself. Okay, let me ask you, where do you see yourself in 5 years?
Like definitely not where we are. Simply doing monitoring and testing. So we wanted to take up.
So you don't ask this question. You answer my question, and then only I can help you understand.
What is the roles and responsibilities for a day to day? Can you guide us?
See, it's all about troubleshooting, right? See, production will have some issues. You need to find a troubleshoot. Performance issues is different than production issues. We can never replicate all the performance, the production issues in performance environment. In performance, the issues comes of different types. So mostly this course is designed from an architectural point of view, the troubleshooting point of view. Okay, are you asking about the roles and responsibility of an SRE engineer?
Yeah.
Yes.
See, so SRE engineers needs to work on the automation, needs to be a performance expert, needs to be a troubleshooting expert. The role is to make sure production is highly available. Anything happens to production, set up the monitoring, set up the alerting. If any issue happens, you want to get alerted. You want to automate the alerts if let's say high response time happen or high CPU happens. Can you automate the troubleshooting way, or can you automate the fix? Or if you want to, if not, can you write the SOPs for others to follow, system operating procedures? So monitoring, alerting, automation, performance, troubleshooting, all these are roles and responsibility.
The DevOps engineer will do, right? Like, they used to set up all the monitorings and everything. Like the infrastructure guy.
Setting up one thing, right? They would not work on production. DevOps engineer will not work on production. You need to work. SRE engineers work. You need to understand the problem. You need to set up alerting, various alerts.
But suppose, like I have a doubt, like if you look at AWS, so we have infrastructure guys. So they used to set up all those. Even they used to take care of the production. They used to alerting system, everything, and they will set up like ICP, all those things.
They are doing a role of an SRE engineer.
Okay.
If you are taking care of production, monitoring, alerting, they are doing a role and responsibility of an SRE engineer, apart from the infrastructure.
Okay.
Yeah.
Okay.
Site reliability engineering. You need to make sure production is highly available, reliable. How can you be reliable? If you can find the issues well in advance, if you can troubleshoot the issues, if you can fix the issue on the architectural infrastructure, issue could be anywhere. On the infrastructure side, on the performance side, issue could be anywhere. Expectation is to make sure production is highly available, reliable. Whatever it takes to do that, SRE is expected to do all of those things.
That's fine, but like response you're just giving is like one line or two line. Maybe like there are
I will do
like something.
I don't know what you're looking for, right, Bala? So full-fledged roles and responsibility. We are discussing this, okay? Full-fledged 2 hours, each and every roles and responsibility. We have a complete session on that. When we talk about SRE, the roles and responsibilities. We have a complete 2-hour session, and I'll go over all of those things. The roles and responsibilities.
Yeah, like we have a problem with Java. Like if you know Java that much high level, so we'll be into the development.
If your question is on the roles and responsibility, we have a full-fledged thing, different 1 hour complete session on this.
Okay.
Okay.
Okay, then are we all good? Okay. So thank you for joining. Let's meet tomorrow to discuss, and we'll start with the cloud journey, guys. From basics, we'll start with the cloud journey tomorrow. Thank you so much, guys, for joining the session. We'll meet tomorrow. Thank you.